Hello everyone. So today we will be learning about chapter 3, right? We have already completed chapter 2, which was about frequency distribution table, histogram, types of graphs, scatter plot, regression and correlation. Remember, it is very important to learn how to construct the frequency distribution table. So I have already put that in the video of section, I guess, 2.1. So make sure go and watch the video again and again until you learn how to construct the frequency distribution table. Because according to quiz 2, like when I saw the performance, I was pretty much sure that most of you do not know how to construct the frequency distribution table. It is very important because in chapter 3 also we will be using the same table. So make sure to learn that perfectly. Now, in chapter 3, we will be learning about measures of center, section 3.1, measures of center. Now, what is this? Remember, we did study about this in chapter 2, right? CV dot. This was also the quiz 2 question, and I told you to explain the terms, but most of you just wrote the abbreviation and did not explain, right? And others, they just explained only two of them among the five. So when I say explain CV dot, you have to abbreviate and also explain each and every term. Okay. Now, what is CV dot? C means center, V is the variation, D is distribution, O is outliers, and T is time, right? So what was center defined as? It is nothing but a representative value that indicates where the middle of the data is set is located, right? And V is the measure of the amount that the data values vary. D is the nature or shape of the graph. O is the outliers. Outliers means the data values which is very far away from the other data values. T is time. Okay. Now we will be studying mainly about this center of measures. Okay. So as I said you, it is nothing but a value which indicates the middle of the data set located. Now if you see the last video of section 2.4, I had explained you that we will measure the center using mean, median and mode. Okay, center will be measured using these three terms. Now which term to choose depends on the situation. Okay, so we will see how to do that. This is some of the round off rules. So for mean, median and mid range, do not round off. Okay, so these three should have a decimal point. Now coming to mode, mode will not have the decimal points. Okay, now notations. So this I had explained you in the first class, saying that this is called as summation, which means the sum of all all the set of data values. X is nothing but the data values. Capital N is the number of data values, or else we can call it as frequency of a population. If you have capital N, then remember it is related to the population. If you have small n, most of the time you will get small n. So if it is small n, it is related to a sample. Okay. Now, first one is mean. What is it? Most of the time, we call it as average. So, for example, average of your test score, average speed, average time, etc. Right? So that average is nothing but mean. But in statistics, you are not supposed to call it as average. You are supposed to call it as mean. Okay. So what does this mean? How do we compute that? So mean is nothing but you will be adding all the data values and divide by the total number of data values. So total number, which is denoted by number of data values, is denoted by n for a sample, and it is denoted by capital N for a population. Okay. So let's see. And in this, one of the main disadvantage of mean is it is very sensitive to the data values, or also called as the mean is not resistant. So what do I mean by resistant? Resistant in the sense, if there is any presence of outliers, which means the extreme values, a value which varies or which lies very far away from the other sample values. So presence of such outliers, if that doesn't cause any change, okay, if that doesn't cause any change, then we call that variable, it might be mean, median, or mode, we call measure those measures of center as resistant if it doesn't change. But in case of mean, if there is any presence of outliers, then the value or the result of the mean changes. Okay, and that's why we say the mean is not resistant. We will see with an example. Okay, and this is the formula for mean. Okay, summation x, summation in the sense sum of what, sum of all the x values. So what is this x values? Data values. Sum of all data values divided by n. What is n? Number of data values in a sample. N is number of data values in a sample. Okay, so this is the formula you will be using. Summation x by small n. Okay, now we have another formula. This is how the textbook will use, but you will also come across these two type of formulas where you will have x bar equal to the same formula, but there is only change in the notation x bar. When they say x bar, that means you will be calculating the mean for a population. Okay, so if the data are a sample from a population, the mean is denoted by x bar. Okay, so you will also be denoting mean as x bar, that's the another notation, and you can also denote it by this symbol mu. Okay, now let's see the example one. So they are asking us to calculate the mean of the first 5 counts. Okay, so let's see. First is 22 plus 22 plus, let me write this down, 22, 26, 24, 23, right? These are the numbers given in the example 1. Now, what is the formula for mean? Mean is equal to summation x by small n, right? Summation x means sum of all the data values. Now, how are you going to compute the summation x? Simply add all the values. Okay, so I will be adding 22 plus 22 plus 26 plus 24 plus 23 divided by number of data values 1 2 1 2 3 4 5, which is n. So n is equal to 5. Now do this in your calculator. Add all the values, divide by number of values. You must get 23.5. Okay, so this is how you compute the mean. Next is median. Median is simply the middle value of the data set. Okay, if you have a raw data or if you have any data set, the middle value of the data set is called as median. Very simple. And it is also denoted by x tilde. Now this is x bar, which is called as mean. This is mean. Okay, now if you have x with a tilde, this is called as tilde. So if you have a notation like this, x tilde, then this is median. So we usually denote it by x tilde or m or med. These are the notation for median. Now the properties is that they say the median is a resistant measure of center, which means even with the presence of outliers, the median will not change. The median doesn't change even with the presence of extreme values. So median is a resistant measure of center. Now, how do I find the median? So before you do anything, it might be median, mode, or mean. Make sure to sort the values in a order, ascending order. Okay, from low to high. Make sure to sort the values. First thing is to sort the values. Next, to find out whether the number of data values means small n, right? It is denoted by small n. So if this small n is odd, if it is odd number, then we say that the median is the exact middle number. Okay, if the median is odd, if the date n is odd, then the median is nothing but the exact middle number of the list. If the number of data values is even, if it is even, then the median is not the exact middle number, rather it will be the mean of two middle numbers, which means adding those two middle numbers and dividing it by 2. That is how we calculate the mean, remember? Okay, now next let's see with an example. Find the median of the first 5 data sets for Verizon. Now remember, what did I tell you? First step to find out the mean is to sort out the data, to sort the data in an ascending order. Okay, now let me write the first value 14.1, next is 22.4, 23.1, 38.5, 55.6. Now tell me what is the median. Remember, next thing what you have to do is to find the small n. N is nothing but number of values. So it is 1, 1, 2, 3, 4, 5. Right? So n is 5, which means it is odd. What are odd numbers? It is simply 1, 3, 5, 7, 9, 11, and so on. What are even numbers? Let me write like this. One, 3, 5, 7, 9, and so on. And 2, 4, 6, 8, 10, so on. So all this black, okay, this black is nothing but odd numbers, and the red ones are your even numbers. Even numbers means any number which is multiplied with, which is divided by 2. A number, if it is dividing by 2, then we call it as even. Okay, in the rest of the numbers are odd numbers. If you are getting confused with this, one simple trick you can do is just try to cancel out the values from either of the side equally. 1, 2, remaining is 23.1. This is the middle number, which is called as median. This is the median. Okay, now we have a same list of numbers, so let's arrange in an order: 23.1, 24.5, 38.5, 55.6. Now what is the small n? 1, 2, 3, 4, 5, 6. N equal to 6, right? It is nothing but the even number. 6 is the even number. So what is the median? If it is even, then the median will be equal to mean of two middle numbers. Okay, now tell me, I will represent median by MED. Which are the two middle numbers? 1, 2. These two are the middle numbers, right? So it will be 23.1 plus 24.5 divided by 2. Okay, so this will be your median, and your answer must be 23.8. Okay, do not round off, leave it as it is. Next is mode. What is mode? If you have a data value which is occurring most of the time, okay, then that is called as mode. For example, if I have a data set like this: 2, 2, 2, 2, 1, 1, 3, 4, 5, 6, 6, 6. Now count the number of, choose the data value which is repeated more number of times. Now 2 is repeated 1, 2, 3, 4. 4 times, right? So 2 is repeated 4 times. 1 is repeated 2 times. 3 is not repeated, so we will not take. 4 is not repeated. 5 is also not repeated. And 6 is repeated 3 times. Now, which is the number which is repeated most of the times? 2, because it is repeated 4 times. Now, my mode is, the mode of the data set is 2. Okay, so that's how we compute the mode. So in mode we have 3 types. Bimodal, which means if you have a two data values occurring the same number of times, then we call it as bimodal. Multimodal, if you have a data value which is occurring more than, if you have more than two data values which is occurring the same number of times, if you have more than two data values occurring the same number of times, we call it as multimodal. If you do not have a value which is repeated, then we call it as no mode. You are not supposed to write mode equal to 0. You have to say no mode if you do not have a data value which is not repeated. Okay. So these are few of the examples. So here, as you can see, let's see, 5.40 is not repeated. 1.10, yes, it is repeated. 1.10 repeated twice. 0.42 not repeated. 0.73 not repeated. 0.48 is also not repeated. Now what is the mode? Mode is 1.10. Okay, here 27 repeated 1, 2, 3, 3 times. 55 is repeated 1, 2, 3, 3 times. 88 it is repeated 2 times. 9 not repeated. Now which are the data values which is repeated most of the times? It is 27 and 55. So there are two data values repeated same number of times. So we call it as bimodal. Okay. Next example. 1 is not repeated, 2 not repeated, 3, 6, 7, 8, 9, 10. These values are not repeated. So we call that as no mode. There are no such number which is repeated more than once. Okay. Now the best thing about mode is this can also be used to find out in the quantitative data. Now here it is quantitative, right? Blood type AB, A positive, B positive, O positive and AB negative, right? So this is the blood type and you can easily say which is the blood type which is repeated most number of times, because the frequency number is high for O, then we call mode as O. This is O letter. Okay, so if you have a histogram you can easily compute the mode. Next is the mid-range. Now, this is not a term which is needed to calculate or to compute the center of measure, but we might need this to construct some tables like frequency distribution. So, what is mid-range? Mid-range is nothing but the value between the maximum and minimum. A value between the maximum and minimum is called as mid-range. How do we compute that? Here is the formula. Maximum plus minimum divided by 2. Always the denominator will be 2. Always. Maximum number plus minimum number divided by 2. Now, is this resistant? No, the mid-range is not resistant, which means it will change if there are any extreme values. Okay. Now, we also have median, right? We also have median. So, the formula for the median was the mean of two middle numbers. Okay, so in median, remember we are not including maximum and minimum, but whereas in case of mid-range you have to choose maximum and minimum. You are not supposed to choose the middle numbers. When you choose middle numbers and divide it by 2, that is called as median. Okay, now example 4, we will compute the mid-range for these data set. Okay, so we will see the numbers are 22, 22, 23, 24 and 26. What is the formula for mid-range? Maximum number plus minimum number dividing by 2. Now in this, which is the maximum number? 26. Plus, which is the minimum number? Even though it is repeated twice, you are supposed to choose the minimum number as 22. Divided by 2 will be your mid-range. Okay? You can follow this and you can also do this in your calculator. Now, so we will do some examples here. So here they are asking us to find the mean, median, mode. Okay, mean, median and mode. What is mean? Sum of all the data values. So add all the data values plus 3 plus 3 plus 4 divided by total number of data values. It is 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 9, we get the answer as 3. Now let's see median. Median is the middle number. Here as you can see it is 1, 2, 3. 3 is the middle number. 3 is the middle number, so median is 3. Which next is mode. Mode means the number of times it is repeated. So here as you can see 1 is not repeated, 2 is repeated twice, no, so that's the least number. 3 is repeated thrice, we will consider this. 4 repeated twice, no. 5 is not repeated at all. So this is the mode. Repeated most number of times. Okay. Now in example 2 or in the group 2, as you can see we have a same data set, only change is in the presence of outlier. Now why do I call this as outlier? Because as you can see it is very far away from the data set. It's very large when you compare with the other data set value. So we call that as outlier. Now what if I have 100 in the place of 1 lakh? Even if you have 100, it is very far away or it is a large number when you compare with number 4, right? So still it is an outlier. Okay. Now let's compute mean for this. It will be 1 plus 2 plus 2 plus 3 plus 3 plus 4 divided by 9. So your answer will be, okay, now median. Now tell me the median. Remember, median is nothing but the middle number. Even in the presence of outlier, which is the most number of time, which is the middle number in the data set? It is 3. Mode. Even though there is a presence of extreme value, which is the number repeated most number of times? 3. Right? It is repeated 3 times. So the mode is 3. Okay. So what can we conclude from this? Observe group 1 and 2. Observe group 1 and 2 and observe the value for mean and observe here also. Right? If you compare that, for group 1 mean is 3 and for group 2 mean is very large number. Why? Because there is the presence of outlier in group 2. And that's why I said in the beginning that mean is not resistant. It will change if there is a outlier present in the data set. Okay. So now as you can see the median and mode, it is not changing at all. We have the same result for median and mode in the two different groups. Okay. Next is with the graph. Now, where have you seen this type of graph? We learnt about this in chapter 2. This is a bell-shaped curve, right? Also called as normal distribution. Okay, normal distribution. Now, I was telling you that we need the variables to be normally distributed. Why? Because if you have a normal distribution, or if the variable is normally distributed, then there is no need to compute all three of the center of measure. If you compute mean, then the median and mode will be equal. So always for a normally distributed plot or a graph, mode, mean and median are all same. So we can save time without computing the median and mode. So there is no necessity to compute all three center of measures. Okay, and that's why we want it to be normally distributed. Next, so here we will be computing mean from a frequency distribution table. Now, you had seen that in the previous examples there was a data values given, right? We had some number of data values already given. Now, in case of frequency distribution table, you will not have the true data values. Instead, you will have a class interval, right? So how do I calculate the mean if I have a class interval? Okay, so we will see that. Before that, let's look at the formula for mean, right? X bar is nothing but mean. Okay, right? So the formula is the same thing, summation x by n, written in the other way, denoted in other way. Now remember, n is number of data values, also called as sum of all frequencies, right? N is nothing but sum of all frequencies. Summation x, you also have frequency in the frequency distributions table, so you will be multiplying and adding the frequency and data values. Okay, we will see how to do that. Now they have given us the class interval and the frequency. So sometimes you will have a raw data, you will have to find out the class interval and frequency and then compute the rest of the uh, terms. And that's why I said it is very important to learn how to construct the frequency distribution table. Okay, so let's get back to the example. Now, we need to find the x. We do not have a particular data value here. So we need to find the x. So how do you find the x? It is nothing but the class midpoint. How do you find the midpoint? It is nothing but 124 plus 75, which means the upper limit. Write it like this. Which is the upper limit plus lower limit divided by 2. Okay, upper limit plus lower limit divided by 2 is the formula for midpoint. Now here the upper limit is 124 plus lower limit is 75 divided by 2 will give you 99.5. Okay. In the same way, compute for this also. Upper limit is 174 plus 125 divided by 2. Your answer must be 149.5. Go on. 24 plus 175 divided by 2 equal to 199.5. 274 plus 225 divided by 2 equal to 249. Now you can ask me, why is it necessary that the first value must be the upper limit? No, it could be lower limit also. Okay, I can also compute by 275 plus 324 divided by 2. I can also write lower limit in the first place. That doesn't not, it is not going to change the final result. Okay, fine. So this is how you compute the class midpoint. Now next is to compute f and x. Okay, this is nothing but multiplication, right? Product of the frequency f here and the midpoint x here. Simply multiply 11 with 99.5. 11 into 99.5 will give me 1094.5. The same way, frequency is 24 here. So 24 into 149.5 will give me 3588.0. Next is 10 into 199.5 equal to 199,995. Frequency is 3. Class midpoint is 249.5, which equal to 748.5. Frequency is 2. Class midpoint is 299.5, which is equal to 599.0. Okay. Now, once you have computed the class midpoint and the product of frequency and midpoint, your final step, or the second final step, will be to add all these values in the last column. So add 1094 plus 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 plus, which, so if you add all these variables, all these numbers, you must get the answer as 8025. Okay, do this in the calculator right now and you have to verify the answers. You have to do this along with me with the help of calculator. Okay, so once you are done with this, our final step is to compute the mean. This is the formula, right? So summation fx is here, which is 8025.0 divided by summation f. What is summation f? Here. Add all the frequencies. And tell me the value. you have to get 50. Okay, and put the same number here and divide 8025 by 50. 8025 divided by 50 should give you 160.5. Okay, now this is called as approximated mean. Not the exact value for mean, but approximate value for mean. Why? Because we have the class intervals, or we can say that we computed mean using class midpoint. We did not use the true value, right? And that's why the result which we get is the approximate value or approximate result. Okay. Okay. So if you're done with this, we will move on to the next topic, that is weighted mean. So this is also the same thing, similar to frequency, right? Because what was the x bar formula for the frequency distribution table? F dot x divided by summation f. So there is only difference with the notation. Here it is f, here it is w, right? W as in weights. Okay. Now what is so much difference between the frequency distribution table and weighted mean? Remember, here we had, for one class interval we have one frequency, and for another class interval we have another frequency. But in case of weighted mean, we will have two frequencies for one class interval. Okay, for example, if I have a class interval between 2 to 5 and my frequency would be 10 and also 11. So you have two frequencies for one class interval. In such case, we will be calculating weighted mean. Okay, let's see how to do that. So here, a student, this is her credits for each course. Okay, for each course, she has this many credit. And according to the grading system, we have this as the credits. So we need to compute our grade point average. So what is average? Mean. So since we have different frequencies and different data values, we will have to compute the weighted mean. The question might not mention you which type of mean to compute, but you have to know that depending on the content. Okay. So let me prepare a table first. We have x value, we have weights, and we need to compute, right? Okay. Now we have A, B, C, and F. So here the x values will be 4, 4, 3, 2, 0. Okay. Now I'm not including D because it is not present here. Now I wrote 8 twice because we have 8 twice. Okay. This is the weights. This is the x values. Now what is weight? It is 3. Here also it will be 4. A with 3. First value. A, 4 credits. So I'm writing 4 here. B as 3. B as 3 credits. C as 3 credits. F has 1 credit. Now multiply these two. 4.3, 4.4, 3.3, 2.3, 0.1, 12, 16, 2 3s are 6 and 0, right? So once you have computed this, next step is to find out, according to the formula, you need summation W, right? So summation W is nothing but adding all these weights. So add all these weights, it will be equal to 14. Now next is you have to add all this x dot W, and this must be equal to 43. Now what is the formula for mean? X bar equal to summation of x dot W divided by summation of W, right? So summation x dot W is 43 divided by 14, 3.07. That is nothing but her GPA, grade point average, right? Also called as GPA is 3.07. Next example. So here we have, so we are supposed to calculate the average of the student who has the following score. We need to calculate the average, also called as weighted mean, of the student who has following scores. Okay, now let's see what are the scores. For exam 1, 90. For exam 2, it is 72. I'm taking all the information from here. Okay, and for exam 3, which is the finals, 81. And for lab, it is 95. Homework is 100. Homework is 100. Quiz is 95. Okay, these are the x values. Weights. What are the weights here? These are the weights. Okay, so for exam 1, exams each count 20%, right? So these three are the exams which counts to 20%. Now the weight is 20%. You are not supposed to write as percent. So 20% converted into decimal gives me 0.2. Right? So I'll write 0.2 here. So it follows for all the exams. For all the exams it is 20%. So the final counts is also 20%. The lab counts as 15%, which is 0.15. And the homework counts as 15%, 0.15. Lab is done. Quiz counts as 10%, which is 0.10. These are the weights. Now we need to compute x dot W, right? And here we need to know what is the summation W. and summation x dot w. Okay, so here it is 90 dot point 2 equal to what? Multiplied. So 72 multiplied with 0.2, 81 multiplied with 0.2, 95 multiplied with 0.15, 100 multiplied with 0.15, 95 multiplied with 0.10. Okay, compute all this. So your answer must be 18, 14.4, 16.2, 14.25, 15, 9.5, and if you add all these values you must get the answer as 87.35. Okay, now to calculate mean, what is the formula? X dot w divided by summation w. Now here summation w will be at all the weights, so you have to get the answer as 1. Okay, so here 87.35 divided by 1 will be equal to 87.35. Okay, now mean, there must be only one decimal places, so round it off to nearest one decimal place, not to the integer one decimal place. So your x bar is equal to 87.4. This is the final answer. Okay, so this is how you compute the weighted mean. Now here are examples which I want you to do now. Okay, find the mean for this data set first and let me know the answer.